These isolated windswept hilltops on the Whāroa Plateau, at around 600 metres above the Raglan coastline, will soon be home to an environmentally friendly energy source, capable of contributing over 64 megawatts of power to the national grid. That energy, enough to power a city of 30,000 homes, will be delivered by 28 wind turbines, each harvesting the natural force of the prevailing westerly winds that howl in from the Tasman Sea. But before those turbines can be delivered and erected, an access carriageway needs to be constructed across this rugged and demanding landscape. Measuring over 40 kilometres, construction of the main access road and branch roads to the various wind turbine locations has provided Hiway stabilizers and their project partners with significant engineering challenges. Constructed on behalf of a Well Energy Meridian Energy partnership, the main contractors for the project are a Spartan Hicks joint venture, with Hiway Stabilizers as their stabilizing subcontractor. During the course of the project, which will take around 9 months to complete, over 200,000 square metres of stabilised carriageway and turbine-based platforms will be constructed. So, starting with this heavily contoured terrain, let's look at some of the unique challenges that Hiway Stabilizers and their partners have overcome. A number one priority has been the construction of this access road, which has also served as a temporary haul road for all earthwork plant. High on the list has also been the need to construct all surfaces to a load-bearing capability of over 200 tonnes. That staggering figure is almost 4 times the specified requirement for a New Zealand state highway. And then there's been these massive basalt boulders, scattered all along the entire length of the road at various sizes, depths and densities. Removal prior to stabilisation has been an ongoing task for the contractors. Stabilising the wide range of soil types that are common to the site has also been a major consideration, ranging from weathered basalt and wet alluvial rock to very heavy clays, sometimes with all three within a single section. Each soil type has required its own stabilising solution. The complex pavement design specifications developed by Hiway Stabilizers' in-house engineers have therefore needed to address the ever-changing demands of this diverse subbase. Hiway Stabilizers' extensive experience and highly specialised stabilisation fleet were major attributes in meeting these challenges, as was the company's ability to bulk deliver project-specific binder blends from its Silverdale blending plant. The wet heavy clays was stabilised using these low-ground pressure-tracked hose, which have traction in even the most difficult of conditions. Because it can remove up to 3 times its own weight, a blend of lime oxide and cement was the ideal stabilising binder for this subgrade. In other sections, subgrade stabilisation was delivered by heavy-duty Komatsu hose, usually in tandem with a secondary hoe, to ensure that final particle sizing met the exacting specifications required by Hiway's design engineers. Because of its sheer size, this has been one of the largest continuous stabilisation projects ever undertaken in New Zealand. And despite its importance to the nation's energy requirements, without the financial and programming advantages delivered by this highly specialised stabilisation engineering option from Hiway Stabilizers, it's unlikely that a project of this scale would have ever seen the light of day.